So we are talking about the quadratic function. So go ahead and write quadratic. So remember how we did the parent function for quadratic? What was the shape called? Do y'all remember? Parabola. It's the U shape. And we have a lot of vocabulary with quadratics. So we'll go through this first one. This is our quadratic parent function is y equals x squared. So let's go ahead and write what the vertex is. Put a point at the vertex. The vertex is the point where it changes direction. So where I put a dot right there, that's our vertex. It changes direction. So this is at 0, 0. Remember, domain is x. You look at your x-axis. Label your x-axis. X-axis goes from left to right. So this one goes on and on forever in both directions. So it's all real numbers. Left and right. There are arrows. And then our range. Our range is our y-axis. Label your y-axis. It's your bottom to top. So the lowest that this goes is at the vertex, 0. And then it goes on to infinity. So we could write this as 0 to infinity. And we use a bracket when it's included. So bracket 0, infinity with a parenthesis. Or an easier way to write it is y is greater than or equal to 0. Because it's at 0 or greater. Our axis of symmetry is a line that cuts the shape, whatever it is, in half. So when we had the V, it was cut in half. And we were able to draw a dotted line down the middle. We'll do the same thing here. So I'm going to draw a dotted line down the middle. And it actually goes through the vertex. So I'm going to call this the AOS. And I'm going to label it on my graph. Axis of symmetry. And so the axis of symmetry is always an x equals wherever it goes through on the x-axis. So it goes through the origin, so it's x equals 0. So if you want to make yourself a note over here, divides parabola in half. That's what the axis of symmetry does. And it always goes through the vertex. So if you want to put goes through vertex. Okay, circle one, maximum or a minimum. Does it have a maximum, which would be the highest point, or the minimum, which would be a lowest point? Minimum, yeah. Because it opens upward. So I'm going to put minimum, I'm going to put opens upward. If it opens downward, it's going to be a maximum. Transformation. This is the parent function. There's no transformation because you always describe what happens to the parent function to get to the new function. It's the parent function, so there's no transformations. I'm going to write none. Okay, one more thing we need to include is the y-intercept. Well, y-intercept and x-intercepts. Okay, the y-intercept is where it crosses the y-axis. So where does it cross the y-axis? Yeah, 0, 0. So make sure you write a coordinate. And then our rocks, write that down. ROXS. This is going to be an acronym for something. So R stands for roots, O stands for zeros, X stands for x-intercepts, S stands for solutions. It's all the same thing, but for some reason in algebra, they want to use different words. So all this is your x-intercept. So up here, let's go ahead and write that. ROXS. We're going to call it the rocks. R stands for roots. O stands for zeros. X stands for x-intercepts. And S stands for solutions. They all mean the same thing. All it is where it crosses the x-axis, where the parabola crosses the x-axis. You could have 1, you could have 2, or you could have none at all. So 1, 2, or none. Okay, so our rocks here, how many times does it cross the x-axis? Just that one time, and it's at the origin, 0, 0. All right, example 1. We have that function, and it's already graphed for us. So then we would need to find our vertex. Let's look at our vertex. It's going to be right there. Put a point at the vertex. And let's write what the coordinates are to that point. So negative 1, 2, 3, 4, negative 5. Negative 3, yeah. Okay, before we move on, let's look at something. We have the equation and then the vertex. Where do you see the vertex in that equation? Right here and right here. But remember that whole crazy x thing? It says plus 5, but when I write it as a vertex, I write it as negative 5 because it's the crazy x. Minus 3 is still minus 3. So that's actually, it's called H and K. And that's where you can find your vertex in the equation, which makes it easy. All right, let's go ahead and do domain. Domain is left and right. It's our x's. So label x, label x. Domain left and right. We have arrows going left and right. So what's the domain? All real numbers. Negative infinity to positive infinity. Okay, and then our range. Our range is our y-axis. So we look down and up. Where is the y start? Yeah, negative infinity. It's all the way down here. So I can write negative infinity because it's going to go on and on forever. And where does it stop? Negative 3. So we always want to go from least to greatest. So smallest to largest. So negative infinity to negative 3. Or we could say y is, let's think about the inequality for that. Is y going to be greater than negative 3 or less than negative 3? Is it higher? Is it going higher or is it going lower? Lower, so it's going to be less than or equal to negative 3. Okay, axis of symmetry. Draw a dotted line going down the middle of that parabola. And label it the AOS. Axis of symmetry is x equals something. What value does it go through on the x-axis? Negative 5. And look at our vertex. Negative 5 on the x. So those always are the same. The x value of our vertex and the axis of symmetry are the same. Okay, maximum or minimum? Do we have a high point or a low point? Maximum. This is our max. And then transformation. So think about our warm-up. Remember the warm-up? These are really similar. You're looking at the same transformations because they're kind of written the same thing. So instead of absolute value bars, you have parentheses around it. So let's see. What did the negative do? Reflect. So that's the first one we write. Reflect across x-axis. Okay, what did the 1/2 do? It changed it's kind of like slope. So normally it's a up 1 over 1 to get to that second point. So this would be up 1 over 2. So instead of it stretching out, it's being compressed. So that's a vertical compression. Of 1/2. So with absolute value, we're able to keep on doing that stair step, kind of like slope, but not with quadratic, because it doesn't consistently go up that same thing. But to get to the second point, you can do that, because you have your vertex, and then you can do your slope up 1 over 2 on both sides. Okay, and then the 5, what does 5 do? That crazy x. It says plus 5, but what actually did it? How did it move it? Left 5. And then minus 3. How did it actually move it? Yep, down 3. Okay, on our graph, we can't actually see the y-intercept because it would keep on going and it'd eventually get to here. So I don't know what that is, and I don't want to put this in on my calculator, but I could, but I'm not going to. So our y-intercept is right around there. So if you just want to label it on this one. It'd be 0, negative something. But I don't want to put it in. Okay, and then our last thing that we need to write is the rocks. Do we have any rocks? It doesn't cross the x-axis at all. So we can write none. Okay, go ahead and do the next one. Example 2. I'm going to give you a little bit of time to do that on your own. Go ahead and do it. Your vertex. 0, 3. Did you get it right? Thumbs up if you did. Okay. Domain. All real numbers. Thumbs up if you got it. Okay. Range. It would be starting at 3 and going to infinity. Thumbs up if you got that right. Okay, good. Or you could write it as y is greater than or equal to 3. Okay, axis of symmetry, that AOS. Did you draw a dotted line? Did you label it AOS? You didn't, do that now. And then we would write it as x equals 0. And it actually comes from your vertex, remember? Whatever the x value is of your vertex is your AOS. So they correlate. And then also look at range. It said 3. Look at your range. At 3, they correlate too. So they're related to each other. All right, do we have a max or a min? Min, okay. And then what's the transformation? Vertical stretch of 2. See how it's skinnier? And it has that 2 up front. Yep, and then up 3. Good. Thumbs up if you got at least one of the transformations. Good. Thumbs up if you got both transformations. Okay, good. And then we also need to write our y-intercept and our x-intercept. What's our y-intercept? Yep, so y-intercept. I always abbreviate it like that. Y and then int for intercept. It's at 0, 3. For the y-intercept, the x is always 0. The y is the number because it's a y-intercept, so the y should be a number. And then our rocks. Do we have any rocks? Nope, none. Okay, notice on our notes at the very top we haven't filled in that big old box. We need to fill that in. This is our vertex form. Everybody go up to the top. Vertex form is y equals a parentheses x minus h squared plus k. And so just like with absolute value, A tells you your stretch and compression, and then H and K tell you your vertex. So I'm going to write that over here. Vertex is H, comma, K. So you can get it directly from the equation. Notice that it says minus H in the parentheses, but in our vertex it just says H. Because remember, it's the crazy X. It does the opposite.